Elle, you want a waffle?
Waffle.
How many radians do you want?
Radian?
Let me show you. The radian is the arc length of a circle equal to the measure of the radius.
What?
Okay, so if you were to take the radius of a circle and put it on the outside of the circle, that's a radian. And there's 3.14 radians in a half circle and 2 pi radians in a full circle.
Cool.
Now this is a unit circle.
I'm still confused.
To make it easier, let's go from radians to degrees so you can picture it better. So give me a radian.
Pi over 6.
So you have pi over 6. And you times that by 180 over pi. And these cancel out. And this you can cross simplify. And what's 6 divided by 180?
30.
So then it's equal to 30 degrees. You can also do it the other way from degrees to radians. So give me a degrees.
60 degrees.
So then that'd be 60 degrees, and put that over 1. That's times 180 degrees over pi. Okay, so if you want to cross simplify this, then it equals to pi over 3. And if you can find that on a unit circle, it's right here.
I get it now.
Oh look, Max left his skateboard here.
Max?
Anyways, do you want to learn how to compute the arc length of a circle?
Okay.
So we're gonna find the angle in a circle. So let's draw one. So right there, and right there. So the first step in finding the arc length is to find the central angle and the radius. So we do that using this very cool device called protractor. And you're gonna measure the central angle, which looks to be about 80 degrees. Next, you're gonna measure the radius in centimeters, which looks about to be 2.4. We're gonna bring that measurements over here to a paper. And we're gonna find the arc length. It equals the central angle times the radius. So then that would be, central angle was 80 degrees. We have to convert that to radians, so it'd be over 1 times 180 degrees over pi, so that'd be 4 over 9, which equals 4 pi over 9. And you want to multiply that by the radius, which is 2.4. And that would be 9.6 pi over 9. That would be equal to, once you put it into a calculator, that would be 3.35 centimeters. And that would be the arc length. Dustin, do you want to explain the area of a sector?
Yes, I got you. Okay, so the area of a sector is the degrees divided by 360 times pi r squared equals the area of a sector. So, in our case, the degrees was 80 over 360, and the radius was 2.4 squared. So then this equals 0.22 times, and that equals 18.1, which equals the area is 4.02.
Wow. Hey, y'all, what's up?
Hey Mike, did you know your linear speed was 10 miles per hour? Did you also know that the linear speed of a point on a rotating object depends on its distance from the center of rotation? Did you also know that angular velocity is the rate at which an object's angle changes in radians?
How do you know all that?
Because I'm more than a lab rat.
Who taught you that?
Dustin. In order to find the linear velocity, we start off with a given radians per minute, which would be 1.5 pi. Then, in order to cancel out the radians, we do 1 revolution over 2 pi radians. To cancel out the revolutions, we do 2 pi r, or 2 pi times 5, or 2 pi times 12, which is the radius, over 1 revolution, and this would be the circumference. So revolutions cancel out, radians cancel out, and then in order to cancel out the feet, we have 1 mile over 5,280 feet. If the feet cancel out, and then we end up with miles over minutes. Once you multiply across here and multiply across here, that comes out to 355.237 over 33,175.21. That then equates to 0.01 miles per minute. And that's our linear velocity.
I'm proud of you, Elle. You've learned so much.
Thanks, Dustin.
Now you know about
Circles.